All right, it says live. We'll go ahead and get started. Hello, and welcome into my channel. I am Professor L, and I'm hosting live streams for math tutoring. And anyone out there that needs help with their math, they are welcome to come and join me. You can post your math problems in the chat, and I'll go ahead and get started. I have decided today to go ahead and continue working the same problem I'm working on Friday. It is a system of linear equations with three unknowns. So I'm going to go ahead and erase, recap from Friday. I was able to solve this system, but not purely using matrices. So what I did was I found one of the solutions, and then I used simple algebra to kind of plug into the system to solve for the other variables. And so I know what the solution is, but I was not able to solve it purely using matrices. I went back in my spare time today and I solved it, and I was trying to figure out what I was doing here. And even though I had the steps in here, I couldn't figure out how I got this negative 14. So I might have sometimes my nerves get the best of me, and I am a little out of practice. So I feel like that's probably what it was. So I'm going to go ahead and try it again, and hopefully we'll just have a smooth, hopefully it won't take very long. And yeah, that's what the plan is. So I am going to go ahead and erase everything except for the system. And we will reconstruct that augmented matrix using just the coefficients and the constants. And then we're going to recall this identity matrix because that's what we're going to be using to solve it. This method is called Gauss-Jordan elimination. And it's not the only way to solve systems using matrices. I also have used inverses, but there are other methods. So I think we'll go ahead and practice this one more time before we get into more complicated systems. I'm hoping over the next couple days that I will get into a system of 4 variables, because again, three unknowns is very doable using basic algebra. However, when you get into 4 variable and 5 variable, it becomes a little bit more complicated using algebra, and that's really where you see the beauty and the practicality of using matrices. All right, so let's go ahead and just reconstruct this 3x3 matrix using just the coefficients. And notice we only have one equation with x and z, and then the other 2 equations are involving y and z. So when you're setting up your matrices, it's very important that you make sure that all your columns have a variable. So the first column, we're going to want to have x, and so you're listing all your coefficients of x. And since we don't have any x's in the second 2, then we're just going to use 0 as a placeholder. And then the second column, we're going to list all the y's. Well, the first equation, it does not have a y, so we're going to have a placeholder there, and then we'll have a 2 and then a 1. And again, there's no one way to solve using matrices. Every step you take could be a different one, and you can still achieve the same results. The ideal goal is to solve it in as least amount of steps as possible. And then the third column, we're going to go ahead and list our z's. We have 1, -2, -2. And really, I'm hoping by having practiced one time, I'm not going to look at my notes, but I'm hoping that I'm going to be able to shorten the steps. So here in a minute, I'll go count my steps and see how many it took me to solve this. All right. So now I've got my 3x3 matrix. Now I need to list a column with just my coefficients for this method. So we're going to have 3, -4, and 5. All right, and I'm going to count my steps. And 1, 2, 3, 4, 5, 6. Looks like 11 steps. That's a lot. And it looks like the solution, we'll go ahead and list it here, is 10, what was it? -9, -7. And just a simple reminder that this is X, Y, Z. This is an ordered pair in the Cartesian coordinate system. And however, it's just a plane rather than a line. So it's not an intersection, it's actually a line that is in a plane in three-dimensional space. So, all right, so let's go ahead and see if I can figure out a really quick first step that might save me some time. And I'm gonna write them in here so we'll keep notes. It looks like if I multiply this first row, if we multiply this second row by a -1, let's see what that does. -1. So we'll say negative row 2, and then we're going to add it. So -2 minus 2 will give us 0. Let's add it to row 3. And then I'm going to replace row 2 for row 3. -2 and 1. We're going to replace, well, let's replace row 3. All right, so let's do it. So we're going to go ahead and copy down the first row because it doesn't get changed any. So it's 1, 0, 1, 3. And then -1 times 0 is 0. -1 times 2 is -2. -1 times -2 is +2. And then -1 times -4 is +4. Let's go ahead and copy this one down. 0, 1, -2, 5. All right. And then you see when you add row 2 and 3, you're going to get 0 here. So let's go ahead and add them. Again, copying down the first row because we're not making any changes. 0, 1, 3. And then we're adding these two, and we've decided we're going to replace, we're going to replace row 3. I think we're going to replace row 2. I changed my mind. So 0 plus 0 is 0. -2 plus 1 is -1. And 2 plus a -2 is 0. 4 plus 5 is 9. And then we're going to go ahead and copy down that third row. We have 0, 1, -2, 5. Perfect. All right. And then now what I want to do is I want to figure out my next best move. And if there's anyone out there that is watching and you want to tell me the next best move, then I would be more happy to do your suggestion and see where it goes. There is strength in numbers, and especially when you're dealing with a more complicated subject, it's best to have people helping you and working together. It's like helping me to help you to help me. It's great. So, all right. So I'm looking at it, and I think if I add these two rows again, I'm going to get 0 here. I don't want 0 there, but I'll have -2. Let's go ahead and add rows 2 and 3 again, and then replace. We're not going to replace row 2. We're going to replace row 3 this time. Let's do that. So we'll write row 2 plus row 3, replace row 3 this time. I'm going to write the matrices here and see what happens. All right, so we've got 1, 0, 1, 3, 0, -1, 0, 9. And then adding these two rows, 0 plus 0 is 0. -1 plus 1 is 0. 0 plus a -2 is -2. And 9 plus 5 is 14. All right, so now I just need to get, looks like this position needs to be 0. So what can I do? Let's see. I need to multiply well, why don't we go ahead and just divide off the negative here, or we'll divide it by 2. Let's multiply row 3 by the scalar 1/2, and then add it to row 1. So we'll say 1/2 row 2 plus row 1. And then we're going to replace row 1. Perfect. All right, so we've got 1, 0, and let's not write this one in there yet because we're going to add and replace. We got to write the second row in 0, -1, 0, 9, and then multiplying this by the scalar. Anything times 0 is just 0. So those first two are 0. 1/2 times a -2 is -1. And then 1/2 times 14 is 7. And then we're just going to add it to row 1 and replace row 1. So we've got 0 plus 1 is 1. 0 plus 0 is 0. -1 plus 1 is 0. And 7 plus 3 is 10. Perfect. All right, it looks like all I have to do now is get rid of these negatives. So I'm going to do that by multiplying by the scalar -1 on both row 2 and row 3. So -1 row 2 and -1 row 3. And we're just going to replace that. All right, so we got this one is 1, 0, 0, 10. This one is going to be 0. 2 negatives make a positive. -1 times 0 and -1 times 9. And then we've got these two are going to both be 0. And then this one's also going to be positive. And then this one will be negative. And it looks like I've solved it. Perfect. And it looks like I've done it in 1, 2, 3, 4, 5, 6, if you're counting that. So that's perfect. I actually was able to cut my steps almost in half. So each time you solve it, you come up with a shorter way. So that was, I really don't think that if you make a mistake, you go back and correct it. It's kind of like Bob Ross says, it's a happy accident, because you get to practice again and then you've refined your method. And I've cut my steps in half. So it's a way of me, since I understand that mistakes are powerful, then in my math and my learning, then I am able to use that to improve each time I work it. I'm getting a little bit better, a little bit faster, and skills are getting developed. So I hope that you all can see that. It's pretty cool. Anyway, I have solved that. I still have half a board. And what do I want to do with the rest of it? These are really hard to graph. I'm trying to think of how I could graph. See, represent that graphically in 2D space, because really this is an ordered pair that is existing in three-dimensional space. So you have the Cartesian coordinate system, but you have X and Y. But what happens is you also have this Z plane that's appearing here. So you also have a Z. And so when you're wanting to graph these, you find 10 in the X direction, and then it would be -9 in the Y direction, and then it would be -7 in the Z direction. So you've got this point that's laying somewhere in this three-dimensional space. And it's really hard to represent in 2D. We still have these negative directions, positive direction will be plus Z minus Z. All right. And that was a really fast live stream. So I wonder, I might hang out for a little bit longer and just try to, we could go ahead and set up another one, or yeah, I'm just not sure what we should do next. Do I even have my linear algebra book in here? I'm sitting here looking at a statistics book. Ew. Maybe one of these days I'll get into statistics. But should we just do something completely unrelated? It says solve the system using the quadratic formula. Yeah, I just picked a random problem in my book. This is a random problem. So if you have a system that is involving you have ax squared plus bx plus c equals 0, then x equals -b plus or minus the square root of b squared minus 4ac over 2a. So we could just practice the quadratic formula, I guess, real quick. So this is saying you have x squared plus 2x minus 5 equals 0. And it does not factor cleanly anyways. So you look at this number, and to factor it, you need to be able to multiply two numbers to get -5, and then add or subtract them to get 2. And you notice that that's not possible. So this is where the quadratic comes in handy. So you just list your coefficients. A equal 1, B equal 2, C equal -5. If I had my linear algebra book in here, I had a problem, I would go ahead and get that out. I would work another one, but I left it in there in the other room, so not prepared. All right, so what we're going to do is we'll go ahead, and all you're doing is you're taking your values and you're plugging in to solve. So this is x equals -b plus or minus the square root of b squared minus 4 times a times c, and it is all over 2 times a. And when you solve, you have 3 types of solutions. You have a real solution, which would lead to 2 order pairs. You have 1 solution, or you could have a complex solution, which is really it's no solution. And when you're talking about solutions, what you're looking at is on the Cartesian coordinate system where it's touching the x-axis. So you're looking at a parabola that has a potential of 2 crossings, or you could have 1 crossing where it's just resting on the x-axis, or you'd have complex solutions where your parabola is just up here somewhere. It's not touching the x-axis. It could be down here, going the other way, pointed down, but it's not touching the x-axis at all. Then that's how you get those complex solutions. So the discriminant, I said determinant because I'm working on systems of linear equations, but the discriminant is this value that's underneath the radical, and it's going to tell you what kind of solution you have. If it's less than 0, it's a negative number, you're going to have your complex solutions here. And if it's equal to 0, I believe it's this solution. And then if it's greater than 0, you have 2 real solutions. So let's go ahead and solve this. It looks like we're going to have a positive and a positive. So we're going to be here. So if you ever want to know whether you're just having what you're not asked to solve, but you're going to determine whether it's what kind of solution, you can just look at the quadratic and you can look at this little value under your radical sign, and it's basically it's the discriminant, and it will tell you what kind of solution if you remember it. So it's valuable. All right, so we have x equals. Now all we're doing is just using order of operations and a little bit of algebra to simplify. So we're just going to row reduce and simplify here. So this is -2 plus or minus square root. 2 squared is 4. And 4 times 1 times 5 is 20. 2 negatives make a positive. So that's going to be positive 20 over 2 times 1, which is 2. So this is going to give me -2 plus or minus the square root of 20 plus 4, which is 24. And that is all over 2. So what I need to do is I need to figure out, let's see, 24 is 6 times 4. So we'll split 24 up and see how to simplify the radical. We've got 12 times 2, and this is going to be 4 times 3 times 2. So it looks like the perfect root here, the only perfect root is 4. So it'll help me simplify it. It's going to be x equals -2 plus or minus, it's going to be 2 radical 6. Because how you simplify this is you're going to say 24 is 4 times 6. And you're going to pull out your perfect root, 2 radical 6. So that's how I found that. And that's over 2. And then we're going to actually simplify this by pulling out 2 from every term. So this becomes -1 plus or minus radical 6 times 2 over 2. Simplify it that way, and so we have this value there. So it's going to give me -1 plus radical 6 and -1 minus radical 6 for x. So we're just locating those on the graph. So it's saying 2 real solutions. So if I wanted to graph that parabola, this is going to tell me my x values. So let's go ahead and sketch it. And then that'll be good. I want to do at least 30 minutes. I did not expect to solve that in such few steps. So that's me learning. And all right, so I have my x-intercepts. So if I want to get a good idea of where this graph is existing in the Cartesian system, what I need to do is I need to figure out what -1 plus radical 6 is. So let's get the calculator out for the decimal approximation of radical 6. I know it's between, see, the other two perfect roots. So the square root of 4 is 2, and the square root of, let's see, the next perfect root would be 9. So the square root of 9 is 3. So it's existing between 2 and 3 minus 1. But we'll say radical 6 minus 1 is approximately 1.4. So we'll say that's 1, and this is 2. And it's right here. Let's get that over just a little bit. And then we have minus is -3.4. So we'll have, let's see, -1, -2, -3. It's on the other side of -3 in here somewhere. So here's my zeros. If I wanted to find my y-intercept, my y-intercept's when x is 0. So I would take this original equation and I would put make x 0. So x equals 0, then those two terms go to 0, and you have, so you just say y equals x squared plus 2x minus 5. And then you would just get y equals -5, because both of those would go to 0. So then you'd have -5 also on the graph of your parabola. And then I could find the maximum value by putting it in vertex form. So we've got this y equals a times x minus h quantity squared plus k. So let's see if we could do that. So we have y equals x squared plus 2x minus 5. So this is going to be, let's see, it'll be x times x plus 2 minus 5. So we've got, oh, well, let's complete the square on it. Here. So there's this method called completing the square. So you would just, we'll say 0 equals x squared plus 2x minus 5. Add 5 to both sides. So we've got 5 equals x squared plus 2x. And then you take this middle term, we'll do it here. You take it and you half it, which would be 2, and then you square it. So that is the number that you're going to add to both sides. So it becomes a 6. So it's going to be x squared. So what in essence you've done is you've made a perfect square. It's going to be x plus 1 quantity squared. Okay, so this is how you complete the square. So then you would just put that -6 back in there. So to make that 0, subtract, well, that's 6, so you're going to subtract 6 from both sides again. So this is going to give you 0 equals x plus 1 quantity squared minus 6. And then you just replace that with y. And then that should tell you this vertex form, this y equals a times x minus h squared plus k. So what this is telling you from the form is that since this is a negative value, then your center is going to be negative if it's positive, because 2 negatives make a positive and the form is negative. And the same thing here. If your form is positive and your value is negative, then that means your value is negative. So it looks like my center, the center is at h comma k. So we have a center at -1, or not the center, the vertex, which is either the maximum or minimum depending on which direction that your parabola is headed. So that'll be -1, -6. And this is where your vertex, your low point would be, since it's opening up. So we have -1, -6 for the vertex right here. It's the lowest value of that parabola. I personally love parabolas. I love the quadratics and the second degree polynomials, and they're one of my favorites. So there's also parabolas. This is a vertical oriented parabola, and I'm just now remembering that there's horizontal oriented parabolas as well. And so maybe we might be able to get into some of those next. Anyway, I think that that's probably pretty good for Monday. Hope everyone's doing well. And yeah, I'll probably go ahead and call it good there. I am not sure what I'm going to do next, but I'll figure out something. I always do. Sometimes I like to sleep on it and just come up with it random that same day. So we'll just see. If you have a problem or a subject that you would like to see me present, please do not hesitate to put in the chat. I would love to do some math with you and possibly help you with your math. I know it's summertime, but some people are taking math in summer. I know when I was in college, I definitely was taking at least one math class every summer, and they can be really challenging, especially if you don't. Like when I was taking math classes, I didn't have a lot of supports, and there wasn't a plethora of YouTube videos. So I would have given anything probably to have a real life person willing to help me with my math. That would be awesome. But I made it anyways, and you will too. But if you ever feel like doing math with me, I would like to be able to do math as a group. So I will manage my expectations in the meantime, and I will just be up here working and getting some skills. And I better stop rambling there and go ahead and get back to it. And yeah, if you watch my videos, I greatly appreciate that. And I look forward to seeing you all next time. So I better sign off, and I'll say bye for now.